Welcome to my PET repair part 3, which is, let's call this a suffer along video. Took me about, I don't know, 10 hours to fix only the dataset. I initially planned to do much more on this episode than just fix the dataset, but I guess this has to go into a separate episode. There won't be a part 4 because this project is finished after this video, but stick along to the end to see how it goes and how it went. But this is a rather long video. It's about an hour, I guess, in the end. And as I said, I took 10 hours of material and condensed them down to an hour. And I just wanted you to see that it's not always roses and sugar. And this really took a lot of effort to get to the point where it is now. And I guess most of the problems I produced myself by following the false leads and by not doing things correctly in the right order. And I had to bring out a C64, I had to repair a disk drive, I had to create disks from a C64 disk from a PC, stuff like that. I had to figure out how to use the Easy Flash. I tried many different methods to get to the point that I could actually test the datasets, and it's all craziness and it's all in this video. So it's a long one, but I hope you enjoy anyway. And drop me a comment at any point in the video where you think, hey, you should have gone this route or you should have done this. So this might be educational, not just for me, but for everyone watching. So please suffer along. Enjoy. Few things have happened since we last visited the PET. First of all, the cream colored nub is in here. It's not glued in yet. It's a 3D printed part and it's painted and it fits nicely and it goes where the old reset switch once was. I did another thing, and that is I did replace the CPU, which I took from the 1541, which actually was a 6502B variant, the 2 MHz variant, and replaced it with a 6502 standard variant, the 1 MHz, actually with the original one from the PET. And it works. And it works reliably. And so the CPU wasn't dead after all. And what I did actually is this. Remember how I saved the BIOS chip? I put the chip into a round pin socket and then with the round pin socket put it into the original socket on the board. And I did the same for the CPU. So I thought, well, maybe the CPU isn't dead after all, but only doesn't make too good contact. And I took another round pin, this time a 40 pin socket, plugged the CPU in there, and then plugged that socket into the original socket, and lo and behold, works flawlessly. Oh, that was the camera. So it was the CPU after all, and the PET obviously does not like to have a 2 MHz CPU inside of him. And that's okay. I ordered 2 more 6502s from Poland for, I guess, €4 a piece, plus €8 shipping. And these should arrive shortly, but, well, the PET works, so all is good here. Today we're going to try to revive the failing dataset inside this machine. This is definitely dead. Not dead, but I guess it has some issues since it won't load any kind of software. And I already tested the brown version I have of the dataset from the C16 or C116 and +4. And I have another one, which is the original Commodore VIC-20 C64 variant with a plug that fits directly into the PET. And since I don't have any PET programs on cassette tape, I need to find a way to load MP3s or WAV files from the net onto the PET. And I found a nifty little mod that can turn this dataset with just 4 wires into a device that can do that, just that. We will give it 2 more things. One is a speaker, so we can hear what it's actually loading, and the second one is a port to plug in the standard audio cable, which then connects to the phone and should turn this into a machine that could load files from the net. I'm pretty curious if this really works, and especially if this works with a PET. And we will see, I guess. Okay, so a lot to cover in this video. Let's get to it, I guess. So in order to repair the dataset, which is inside the PET, it's just screwed in here, and it's held on with those metal tabs, and it's just a standard cassette tape player. And I will screw this out and then we'll take a closer look. Well, the PET does look a bit naked without its dataset. Okay, so this is kind of a standard tape player from the 70s, I guess. Commodore just sticky taped the metal bracket down here, removed the battery compartment, and brute force cut out a piece of plastic to make it fit inside the PET. So all there is to it really is these 2 metal brackets that make it a special Commodore brand, plus the label on top. Would be interesting to find out what kind of tape player this was before its life as a Commodore dataset. But we'll maybe get down to that later. Let me just unscrew. Now there's just that bracket screw left, which is screwed inside some metal post. That metal post is connected to the screw on top, and it seems that post's actually turning while I'm turning the screw, so I guess I need some needle nose pliers to keep that in place while screwing. Oh yeah, that's, I guess, better, but okay. So here's the belly of the beast. Let's take a closer look. So the rubber band is quite worn out. That may be one cause of failure. Oh, I just noticed there's no counter on here, like on the standard C64 with 20 data sets, because that counter has a separate belt. All it seems okay, but the belt is really, you can see that the wheel is moving still when I'm double pulling the string here, the rubber belt, and that means that the belt is not making good contact. So this may actually be our first point of failure. Get the belt under this without actually dismantling the whole thing, I guess. Let's see. Yeah, just came right off. Okay, so I guess I will clean this whole thing with some isopropyl alcohol. And now we need some replacement. And I got these, but they are a little bit thinner, at least I guess they are almost just half as thick. But I will still try to use these. Bought these in a pack of 50 for $5 on Amazon. So let's see. You can see now the wheel is moving correctly. It's moving up and down, and that tells me all is well. Could maybe even try, that's a little bit too small. Okay, so that might actually fix the belt problem. And this dataset is from 1977. Don't know if you can see that right here, 1977 Commodore. So at least the PCB is some genuine Commodore product, even though the dataset may not be. So let's put the cover back on for now. And let's see what we got. No need to put it back together completely, just so much that I can test it on the PET. And my first test would be to save and load a written program, and we'll do just that. So the PET is back on the bench. Let's turn it on and see if it still works. And that looks completely normal and alright. Let me quickly grab a tape. I got a fresh, or let's say semi-fresh tape with some music on it. And if I'm not completely mistaken, I did actually write a program onto that using an original Commodore C64 dataset. So let's see if this loads using our hopefully fixed dataset. So the wheels are turning nicely. No stuttering or anything. But let's see if we get something on the screen. Okay, that does not look too promising. So that could actually be due to the fact that the dataset is a little bit differently adjusted, the read or write head. So I'll just turn this. Oh, that's a lot of empty tape. Turn this here. Put this tape back in. And we will quickly type up our own program. And we will save this. We'll call the program Horst, just because we can. And press record and play on tape. And it's writing Horst. This only takes a few seconds. And there we are. Okay, so let's rewind this. Looks good. And let's say new first. So program is deleted. And let's do this real Commodore way with a shortcut, which is L and Shift O for those who don't remember. And let's try to load. So if this works, it should find Horst pretty fast. There are actually some caps on the PCB of the dataset, so if all this doesn't work, we may have to change the caps on the PCB. And this does not seem to work at all. Okay, so replacing a belt seems to be just part one of this repair of the dataset, and I guess we are up to some soldering. So off camera I tried to clean this wheel inside here, which does the transport, and as you can see, that was really dirty. So that's another thing done. Let's turn this around. I already removed that one screw that was over here. Okay, so all this is in here tight, so you have to cut this cable tie to get to the bottom of things. Let's cut this 40-year-old cable tie, and then we can just get a bit more room. Not much, because it's all cabled in here, but a little. And then we get a glimpse at the PCB, and you can see there are two caps right here, and here, and here. And on first glance, all that looks okay. Interesting that there's another cassette port right here, so you could theoretically plug a cassette into a cassette into a cassette. So while probing around in this construction, the ground wire came loose, and I guess this might have been the reason why this thing is not working. I have to so let's get that sorted on there again. That is that. Okay, the other wires seem to be in good condition. And now we go and desolder the caps. Okay, so just to make sure that it's not the tape that's giving us some trouble, I brought some different types of tape, because I just recognized this says Chrome Super 2, and on the cassette it says position high. I'm not quite sure if there's some kind of switch on the classic stereo tape decks that lets you set this to a specific type of tape. And just to make sure, I brought some different tapes, and we'll check if that makes a difference and if this machine works at all. Still, I'm always surprised when this comes up and it just works. Can't say anything else. So. Okay, so we will again type in our famous Hello World program, and I'm getting quite used to the keyboard actually. And we will save this again. Wait, we have to wind the tape forward a bit to the good tape, away from the blank tape. Okay, so here we are. Put it back in. Save. Let's call this try 1. Even though it's try, I don't know how many. And off we go. And here we are. Okay. So let's rewind this. Not go quite that far. And oh, wait. Commodore Pro. Let's see. Not quite sure what else could be wrong with this dataset. But obviously that did not do the trick. So maybe we try this tape on the second port, because it was on the second port that we actually could save a program, and maybe that is kind of the problem here. Let me just get this a little closer. Put this into the cassette port, and I guess we'll do all this again. Still works, always amazes me. It's writing away, I hope. So if this works now, this would tell us that actually the cassette port doesn't work, the internal. That again would mean that probably the PIA chips, or the VIA chips, I'm not quite sure which is which in the PET by now, does not work correctly, and that would be problematic, as I don't have a replacement for that. Other than the Spectrum or any other machine, any other not Commodore machine, you can't hear a thing here. That's what I loved about the Amstrad CPC. You could simply turn the volume wheel and listen to the data getting into the computer. But nothing. Okay, so I guess I'll try the other Commodore dataset on port 1 next. I will plug this into the internal port, the port 1, and see what goes. Oh, I can place it here. Oh. Okay, where are my glasses? So I always forget there's no eject button on this thing. Switch the machine on, and will it still work? Oh, it does. That's pretty cool. Okay, so, and off we go again. 10. It's writing, and it's okay, but it did that before. So let's rewind. I will again. And this actually worked one time before with this dataset, saving and loading files. I can't quite make out why it doesn't anymore. So maybe the chips responsible for the tape handling are actually faulty. I'm tempted to try a different kind of tape. This one is FE1, which is iron instead of chrome. So luckily our program is still in memory, and we can just save, try 4. So next up we will try the same dataset on the back side of the PET, so on port 2. Okay. Okay. So I think I will change the drive belt on this drive too, and see what goes then. Okay, so it took me a minute to change the drive belts. And let's try loading again. We are on port 2 still, so we can just repeat this. And away we go. Oh, and look at that. Found drive 5. Loading. So, awesome. So at least this original Commodore 64 VIC-20 dataset now works. Didn't do any cleaning or stuff like that. No recapping, just changing the belt took a minute. That's good news. So we have at least one working dataset to store stuff on. So in order to adjust this read head, you have to have a very, very tiny screwdriver, and it has to fit in the hole and it has to get to the bottom of that, down there. And then you can try to grab the screw and just slightly turn. I will give this, I guess, not even half a twist, just a quarter twist. And let's see if this does the trick. So that dataset works, that's nice, but of course I want the original dataset to work inside my PET. We know there's a program on this tape. So now we can use this tape inside the original dataset to get that to work. So maybe it's just a read head to adjust, and since there's no hole for that on the other dataset, I'll have to see how to do this. So I actually found out that there is indeed a hole in the dataset to adjust the read-write head. It's just not visible if you have the door closed. It's right here. I will just do the same thing as before. And you have to press play, of course, because you need to get the head up. And I will try to reach that screw, there it is, and will turn the head just about a quarter turn. And let's see what happens. Well, I would call that not working. Fun fact, the Commodore datasets are actually kind of an analog to digital converter. Other than the Spectrum and the Amstrad CPC, the conversion is not done inside the machine or the computer, but inside the dataset. So the dataset actually does send 0 or 5 volts as a square wave, and for that it takes the audio waves, which are normally sinus waves, and converts them to those square waves, which are clear 0 or 1 or 0 volts or 5 volts. If that doesn't work correctly, you will not load any program inside the machine. So no luck here. Quick update on the dataset from the C64 VIC-20 using port 1 of the PET. I can report it does indeed work, first try, even so it says try 5. So that's good to know. So all the technical aspects of the PET seem to work fine, as far as I've tried and tested. It's just that the internal cassette drive doesn't work, and I'm on it still. But the idea is to get this dataset working, and I've done some more testing and probing around, and it seems like the read-write head, which is this one over here, is actually defective and I have to change it. Since I don't have any spares, I'm going to use this dataset as a donor, and I will try to use this read-write head, which I know works, in this dataset. I have no idea if this is going to work, but as you can see, the counter is defective, so this doesn't work. So I will use this dataset to do some modding, and I will add a input jack to be able to directly load games from my smartphone in MP3 into this or over this dataset into the PET or the C64 or any other device that can take this dataset. So it's basically an analog digital converter in the end, and I won't be using the read-write head anyway. Okay, so this is pretty much all there is to it, and as you can see, all the wires are okay. This is a demagnetizer head. I learned that. So this would be number one, and then we have our second device, which is right here. Hopefully this dataset comes apart just like the other. Yeah, it looks pretty much like it. So here are 1, 2, 3, 4 screws holding this whole thing in. This mechanism is actually a little bit more complex. As you can see, here's a second belt that's driving the counter mechanism, which actually works, but has a broken off reset switch. Okay, here we go. Okay, soldering iron is heating up. The whole head assembly seems to come with this piece, which is different on the other one. So I guess I will really only switch out the head and hope that will work. Under the head there's a little spring, which you might not be able to see. Try to get a close up. Down there is a spring under this screw to enable the head to level up and down a little. That's where you put the screwdriver to adjust the read-write head. So we have to transfer this screw. Oh man, don't know if this works, but we will see. So this is a 3-piece assembly. There's a spring, that washer goes on the spring, the screw screws in there. And now we will get to the donor and grab the head from there and hope that this is somehow compatible. Here we are. Perfect donor head. And as you can see, these pretty much look the same. So let's switch the head. That is a defective head. That is the good head. Okay, so that is on there. Let's put this back in here. Close this up. there's no movement in this whole thing. Time to put this back into this. Oh, there comes the screw flying out. Take care of this in a minute. Just hope I wired this correctly. But we will see, I guess. Oh, okay, that went in there faster than expected. That is connected. Let's switch it on. Dataset is connected. We have our known good tape. Oh, what's that? That's not good. Oh man. Oh boy, what's that now? Oh, this PET is really killing me. Okay, one thing after the other. Let's just turn it off. And let's check if we can get the dataset to work first. And then we will take care of this other problem, whichever that may be. So, load. Okay. And the dataset doesn't do anything. So there seems to be a problem. So what could this be now? So I did read up on these lines on the screen, and turns out these are faulty video RAM chips. But as so often with this machine, it just seems to be a problem with a socket. So I simply pushed the memory chips back in a little further, and voila, no more lines. But this still leaves us with a non-working dataset, which I have no clue why it doesn't work. Oh, actually, I think I do have a clue. That cable must have come loose. Oh man. Okay. So these brittle cables, I guess, I don't actually know where this goes, but I assume it goes with this one right here on the leftmost side, the orange or red one, orange. So I will try to fix this and then we'll see what goes. Again, oh man, this machine is killing me. I did fix the cable. It's not pretty, but I had to add some strain relief because the connector is already brittle. And well, I guess we are up for our next try. Let's see if the PET still works. It's a jinx or almost. And it does, yeah. Okay. And the tape deck works. That's good news. Just quickly rewind that and see what happens. Okay, searching. So even if I did wire the head, look at that! This is unbelievable! It did indeed work, and it was a defective head. That's crazy! Yes, success! And as you can see, it's really the original PET dataset. So the PET is back up, and with the original drive back in, we'll give this one last try if it still works. And if it does, and if I can type load, I will consider this a fully working PET 2001-8. It's again not working. Let me investigate. In order to get those data sets adjusted, the heads adjusted, I need some kind of head adjustment program, which I don't have on disk. And I already brought out the trusted C64. I had to readjust the head on my 1541-2 because I did encounter some nasty disk rot on some of the disks, and I didn't pay too close attention, and you can't always see it as clearly as here. Sometimes it's just some very slight gray lines which look like track marks on the disks itself, and your head gets dirty, your disk head, read head, and disks won't read anymore. So I had to clean this one. Then my phone gimbal died, so I can't do these nice floating shots. I have to walk around with my tripod now. And I was looking for a method to just transfer D64 image files to a real 64 disk, because you can't do track adjustment on an emulator. So I had to come up with a method, and I have an Easy Flash 3 which sits right inside this white casing which I 3D printed, and from there goes a cable to my Windows PC, which is actually sitting under my desk and behind the door, so I can close it down if I don't want to hear it. And on my Mac I have remote desktoped right inside that very Windows PC. And what you can do with an Easy Flash is you take a disk, put it inside the 5041, which is connected to the C64. Then on the C64, which image can you see? You can see here. You go to the menu, then you turn to the Windows PC again. You download Easy Transfer from the website of the Easy Flash 3. You go to Write Disk, select a D64 disk image. I will use the head tester image. You select the drive number, which is usually 8, and you click Go. And then on the C64 side, this whole thing will start formatting and copying a disk from your PC out of a D64 archive onto your C64. And this takes about 50 seconds. And then you're good to go, and you have a perfectly written disk. Doesn't matter how much stuff is on the disk, it always takes about 50 seconds. And that's pretty neat. And before I managed to get my 5041 running again, you see it's verifying already. Before I got my 5041 ready, you can also start programs or PRG files from your PC on the C64 the same method. You go to the menu of the Easy Flash, you start the Easy Transfer program on the Windows PC, you select the PRG, press go, and it starts the program on the C64. So this is done. It says waiting for command from USB. You can copy another disk or do whatever you like. And as you can see, we have a disk which is still in here. And let's try to access this from the C64. So I will reset the machine. And there it is, head tester. So if you don't have any other construction which allows you to connect a 5041 to your PC or something like this, Easy Flash is a pretty reliable and easy way to do this. It's about, I guess, 40 euros or $40, depending on where you are. As I said, I 3D printed my own case, so it's just a naked module. And it seems to work great. So let's load this up. And see. There we are. Great. So let's try to adjust some dataset heads. After adjusting the head using the head adjust software, which I copied to the disk via my trusted Easy Flash 3, I actually managed to get this dataset to work again. So the head from the PET dataset wasn't broken at all, and the current state of this is I can load and save programs with the dataset. So it's all adjusted. I even fixed the stuck eject button. Had to adjust a little metal clip which pushes the door out, and this thing is good to go. So next stop will be to get the actual PET dataset to work, and my goal here is to get it to a point where it can read its own written programs. So I'm not going to try to load some C64 games on this, because there's no point. I don't have any original tapes, so if I'm able to save software with this and load it again, then I'm good to go. This actually still has the other head. I had to switch the cables around because I did actually solder it the wrong way around. Let's have a short intermission here. When I first opened up the Commodore PET original dataset, the read-write head had two wires on it, a white and a red. The white wire was on the left side and the red wire was on the right side. When I opened up the CN2, the original C64 dataset, it also had a read-write head with two wires, but the wires were interchanged. The red wire was on the left side and the white wire was on the right side. So when I did the head switch and I took the head from the CN2 C64 dataset and put it into the original PET dataset, I actually did wire the head exactly like it was originally in the original PET dataset. So white wire on the left, red wire on the right. That was all completely correct. Then, after some failed read and write attempts, I went on and switched the wiring because I thought, maybe the wiring was exactly like on the CN2, the C64 dataset. I had taken pictures from that, but I didn't watch the material I had on video. So I was convinced that I had accidentally wired the head the wrong way around. And that led down a completely different rabbit hole. And that is where we are at this point in the video. Floppy's on, that is on. By the way, this is a C64 I cleaned in the last video. And we will go and load the head tester, as it is called, which actually originated from a German disc magazine for the C64 called Input 64 or Input 64 as we called it back in the day. And the idea is to screw or to put the screw completely down of the head, so tighten it as much as you can and then slowly loosen the screw until there's a straight line while the tape loads. Problem here is, other than on the, let's say, newer Commodore datasets where you have these holes in here, there's no hole on this one. And you have to have the door open, which pretty much makes it impossible to load while turning the head. So I guess we will just press play. There's nothing here, which is quite strange. Okay, let's probably try to load a good game, which is Kung Fu. Classic. Something's wrong with the tape, I guess. So let's see what happens. If we get anything. And no, there's pretty much nothing. Which is really, really, really strange. Because I did load and save games with this exact dataset. Let's try saving something. Okay, it did save. So one could think that it also should load. No, it's not going to load that. Okay, so I guess we are back to square one with this one. All I want from this dataset is to read and load its own data. Not more, not less. And it all seems to be in perfect order here. The head seems to be pretty straight. So, just out of sheer devastation, I'm going to resolder the head again. Just need my and it's right here. So let's do this again. So now the read-write head is wired exactly like it should be. White wire on the left side, red wire on the right side. This is correct for the original PET dataset. It is not correct for the CN2 or original Commodore dataset, which has the wire switched around. Don't know why. Thanks, Commodore, I guess. So let's test this, I guess, again. Hey, look at that. So the head was the wrong way around again. This is completely nuts. I did load a tape with this other variant. That's just crazy. And look at that, there's a perfect line. At least one perfect line. So let's see if we can improve on that. I'm almost willing to try to load the game. So let's try to load GR Kung Fu. Look at that. GR Kung Fu. It is unbelievable. Okay, so we will not load GR Kung Fu all the way. Interesting, still trying to load. Instead, we will do the ultimate test, which is trying to load and save the program with the same dataset. So 10. So that does not work. This is crazy. It doesn't read it anymore. Okay, let's check with the head adjustment tool again. It's clearly a line. And there's the other data. So there must be some kind of failing component inside this thing. I have this crazy feeling that when reading a tape, it's getting deleted. And that would mean I killed Jia Kung Fu and I did kill Master of Magic. No, there it is. Theory debunked. Just give this a little turn. Let's see what happens. Oh, now it's completely gone. So this is non-deterministic. Obviously it sometimes works and sometimes there it is again. Man, that's crazy. So there clearly is some kind of fault with the whole mechanism, I guess. No, it doesn't work. And now it works. Okay, that does indeed explain a lot. So there's obviously some mechanical defect to this whole thing, not just the read-write head, which obviously wasn't dead at all. Okay, after all this time, I finally found what's going on with this thing. Obviously it has a mechanical defect that sometimes let it load and probably let it save and sometimes doesn't. Open this thing up again, I guess. Oh wait, there was a cable actually tied to this thing right here, and that should normally push this button down here. And maybe this was the reason why this didn't work and write. But it's really a shitty construction. Some really crazy thing if this would work now. If it was just for some cable and some bent metal. Oh man. I mean, I would be really glad, but on the other hand, you never know. Okay, did save, I guess. Now let's see if it loads. It is unbelievable. It did actually find test 4. And here's the program. The pad is back, and as you can see, it has those lines again, and I know that if I push here, which is the video memory, the lines go away. So if you have a faulty pad with those lines, try pressing on the video memory chips. But we are here for the main attraction, which is the dataset. Do this fresh and say new and 10, print hello, 20, go to 10, no, doesn't matter anyway, save, final test, hopefully. Let's do this. Okay, let's rewind, let's say new, and let's say load. And let's see if we get our final test back, which would be amazing. And the end of this little journey trying to fix the PET. And it did find final test. And now for the main attraction, Yes, 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 yes. Oh, I could cry right now. It works. It works. Oh man, that was one hell of a long journey, which took me 5 days. No, not full 5 days, but 5 days on and off work on this. And I guess I have about 6 or 7 hours of material, switching heads, doing stuff. And I guess this video will be about 10 or 15 minutes, so I won't bother you with all the fails. But this is the PET. And I will put the dataset back in. And that will be it for now. I really did my fair share of retro repairs in the past, but this machine really took the cake. I guess I spent about 20 hours trying to fix the various issues with this machine. I'm very happy with it. It's actually right behind me, looks like brand new. So it was worth every minute, but especially repairing the dataset was a real hassle. It almost killed me because there were, I guess, errors I put in myself, like the read-write switch. I'm pretty sure I did this cable mess in there that led to the stuck switch. Maybe it was a little broken or a little stiff in the beginning, but that really took it. So what did I learn? I learned that PETs have really unreliable sockets for the chips, so you should probably switch them all out, but I try to leave it as stock as possible, so I just put in some extra sockets on top of the existing sockets. Some round pin sockets work pretty well. If your video memory fails, just push on it. If your CPU fails, just put it in a round pin socket and put it back in. Maybe it works. There were actually no defective parts inside this machine except for one little broken off leg on the ROM chip. So that was all there is to it. And of course the worn out rubber belt on the dataset. And I'm fairly sure that the worn out belt on the dataset actually was the only fault in the end. I unnecessarily went down this rabbit hole, and I could have just used the track adjustment software in the beginning before switching out heads and stuff, just to check if all was good, but I didn't want to invest more time to get a program on disk on the C64 and stuff like that. But as it stands now, kids, don't do this at home. Use the right tools at the right time. Don't follow any false leads. And learned a lot again. Still learning. And I hope you liked to suffer along. And until the next video. Bye-bye. This is Retro is your new black. If you are new to the channel, please like and subscribe. Thanks for watching, and until next time.